Hello and welcome to Algebra 2, Chapter 9. We're doing 9.1 today. And Chapter 9 is called Rational Equations and Functions. And it's going to take us a few sections to really get into our rational equations, but remembering that any rational number is a number that can be written as a fraction. And this is why I require you to do everything in fractions, because if you know your fraction rules, then this chapter will be a little bit easier on that aspect. So before we get into rational expressions and equations, though, we're going to talk about inverse and joint variation. Alright, we're going to start out by talking about direct variation and inverse variation. So direct variation has this equation, y equals kx, and you would say that y varies directly with x, or as x goes up, y goes up. Let's see if we can do the same symbol there. As x increases, y increases, or as x decreases, y decreases. So if you have a job and you're getting paid, the more hours you work, so if hours go up, then your paycheck goes up. And that would be a direct variation. Okay, versus an inverse variation, which is y equals k over x. Y varies inversely with x, so as one goes up, the other goes down. So we would say as x increases, y would decrease, or as x decreases, y is going to increase. So if you're a runner, the faster you run, so your speed is increasing, the less time it takes to get someplace. And so then your time would be decreasing. Okay? Let's say, the more you drive, the less fuel that's in your tank. That's an inverse variation. Okay? K in both of those instances is a constant of variation, and it has to deal with the situation. And so if you're talking about like a paycheck, if we're doing direct variation, maybe K is how much you make an hour. Let's say we make $8.75 an hour. So X is hours. As X goes up, then Y goes up. Well, K is that amount of money that you're going to be making. So our first task is going to be to see if these are direct variation, inverse variation, or neither. And really what you're looking at is, can it be put in this form for direct variation or this form for inverse variation. And so you see here on the first one, to start out with, it's not in either of those forms. In fact, y is by itself in both these forms. So if I divide by x to get y by itself, I get y equals 4.8 over x. And then does that look like either of my variations? It now does. That is inverse. All right. So looking at the next one, and you can't always tell from the beginning. So let's get y by itself, because you might say it's inverse or something to begin with, because it has that division in there. But we're multiplying by 1.5, so that y is 1.5x. And then if you look at it like that, what is it? That is direct. Right? There's your k value. Y equals kx. And the third one here, y equals 3.5x plus 5, well, that's going to be neither, because neither of them have that plus 5 in there. Okay, so no plus 5. As a side note real quick, hopefully you noticed that this direct variation is the equation of a line, and that's the equation of a line that would go through 0, 0. Okay, and direct variation will always go through 0, 0. This down here also the equation of a line, but would not go through 0, 0. So the next thing we're going to do is we're going to write an equation. And it's going to tell you in what form. So it tells us that they vary inversely. So I'm looking at this kind of equation here. Okay. And y is 6 when x is 1.5. So your first task, when it says write an equation, is you have to find k. This is the first thing you have to do, find k. So I'm going to write my equation, y equals k over x, and I know that I can have y is 6 when x is 1.5. Can I solve this for k? What do I do to solve for k? I'm going to times both sides by 1.5. Those cancel. So k is 9. Now that's not your answer because it wants you to write an equation that relates these two. This does not relate x and y. That just tells you what k is. So my equation that relates x and y is y equals 9 over x. So you have to find k and then plug k back in. So there's my equation that relates x and y. And then I'm going to find y when x is 4/3. So I'm looking for y when x is 4/3, and we're going to do a little bit of multiplying by the reciprocal because that's how we divide fractions. We get 27 over 4. So let's try that again. Okay, and some of them are going to say directly, some say inversely, so watch that. So this one again says inversely. So if I start with my inverse equation, I have to know what k is. That's my one unknown. X and y have to stay x and y. So I'm going to plug in the two values they give me. Y is 7.5, x is 2, and I'm going to solve this for k. So if I multiply by 2, I'm going to get k equals 15. That does not relate x and y, so I need another equation. 15 over x, that's my equation that relates x and y. And then the next step is to use the equation to find y when x is 1.2. So 15 divided by 1.2 happens to be 12.5. Alright, so can you look at data and answer the question, do these show an inverse variation? Okay, well, if we consider, let's consider the top x and the bottom y. That's usually how they give you a table. My inverse, right, would be k over x. Well, if I can take this and solve for k, k would have to be equal to xy. If I multiply both sides by x, okay, well, so let me see if these have the same k value. So k is x times y, so that's 18. 4 times 4.5, 18. 6 times 3 is 18. Hey, they all happen to be 18. Because they all have the same k value, this is a inverse variation then. So we happen to have found our k value. Y equals k over x. There's your model for that. So there is a third type of variation we need to talk about, and it's called joint variation. And it occurs when a quantity varies directly as the product of two or more other quantities. There's still a k in there because there has to be this constant of variation. But for example, you would say that z varies directly with the product of x and y, or with x and y. Something to keep in mind is that directly is always straight across, so directly ends up here on top, directly. Inversely is on the bottom. Okay, so you have direct is straight across, inverse is on the bottom. So now we're going to write some equations, and so we have y varies directly with x and inversely with z squared. So y equals, so directly with x, so x goes on the top, inversely with z squared, so z squared goes on the bottom. And what did I say that we still had to have in there? We have to have a k, and your k always goes on top. So looking at the next one, y varies inversely with x cubed. So where does the x cubed need to be? On the bottom, and then we're just going to put our k on the top. And our last one here, y varies directly, so let's see here, y varies directly with x squared, so x squared on top, inversely with z, so z is on the bottom, k on the top. Okay. Two more, since we haven't done any jointly yet, z varies jointly with x squared and y. So jointly is the product, so we still have to have a k, and then it's going to be x squared y. And then our last one, y varies inversely with x and z, meaning x and z are both on the bottom, k on top. All right, that's what we have for 9-1. Please let me know if you have any questions, and if not, I will see you in class. Have a great day.